Hi everyone, welcome to this Ashbourne Maths video. We're looking at differentiation, the first of 3 videos. We're going to start by asking the question, why do we bother with differentiation? A very good question. Now, we've got 2 curves here. We've got a straight line and a wavy curve. Now, we're very used to working out the gradient, or maybe we call it the steepness. Steepness of a straight line, aren't we? We just use change in y over change in x. Yeah, and that seems to do us proud. It got us through GCSE, fantastic. But what happens in a curve like this is that the gradient or the steepness is constantly changing, right? So this is changing. So we can't just use our old friend. We need a new method. We need to have a way to work out the gradient on different points of a changing curve, okay? And that's where we use this thing dy by dx. That's where we differentiate. When we differentiate, it gives us an expression for dy by dx, and that helps us find out the gradient at different points along this curve. Now, another question you might ask is, why do we care? Why do we care so much about finding the gradient or differentiating? Well, we give so much time to this thing. What's the point? Well, rate of change is an incredibly important concept in maths and physics. It's about how quickly is something changing. Is it getting faster? And if so, how quickly is it getting faster? We could think about a rocket. We could think about a population growing. How quickly is that population growing? We might want to think about, okay, I've got a couple of examples here, like a ball flying through the air. How quickly is it changing speed? We need to be able to model that. Or all sorts of forms of transport, a bike, or if you're running, or vehicles. How fast are they moving, and what's their rate of change? Is it slowing down, and to what extent? Or even the spread of a virus. What's the rate of change of that? It's massively important in our understanding of how that thing works. So that's why we do so much differentiation, because we're trying to find the rate of change, or in other words, trying to find the gradient or the steepness of a curve. Okay, so rate of change is the same as the gradient. Okay, now I want to say a couple of points before we get into the real good stuff of doing an example. Number 1 is, say we've got something like y equals 3 over x. Well, what you've got to do before you try and differentiate that is you must write this in index form. Okay, so this would be 3 times x to the power of minus 1. Okay, a lot of students make the mistake of trying to differentiate this thing, and they'll get themselves into all sorts of bother. Now, once we've done that, then we're in a position to differentiate. Dy by dx equals, and hopefully you remember that we take the power and we multiply it out the front. So then this becomes minus 1 times 3 times x to the power of, well, we decrease the power by 1. So I've gone from minus 1 to minus 2. Okay, so that's what's happened there. Okay, and then now I can now simplify this. This is minus 3 times x to the minus 2, and I can go one step further. I can rewrite this as minus 3 over x squared, although that step might not be completely necessary. Okay, and I'm done. The second thing I want to talk about is tangents. Okay, tangents to the curve and normals. Okay, now these are straight lines. Okay, that's the first and most important thing to remember. Tangents and normals are straight lines, so they're in the form y equals mx plus c. So if I just come over here, I've carefully crafted a curve and a straight line, which I'm sure you'll love. It's y equals mx plus c. Okay, we know how to find that equation, don't we? We need 2 things. We need A, we need a point, and B, we need the gradient. Okay, if we've got those 2 things, then we can find the equation of this line. Now, instead of it just being a random line, this is now going to be my tangent, okay? So remember, a tangent is defined as something that just touches the curve at a point, okay? And it has exactly the same gradient. The tangent and the curve have exactly the same gradient at this point P. The same thing applies. All we need is a point and a gradient. Now, we've got the point, haven't we? We've already got the point. It's where it touches on the curve. But what about the gradient? Well, the gradient, happily enough, is the same on the curve as it is on the line at this point P, okay? So for this point P, the gradient on the curve at point P, this gradient, whatever it is at that exact point, is going to be exactly the same as the gradient of this tangent. So that is why we can use dy by dx to find out the gradient on the curve, and therefore it's going to be the same as the gradient of that line. Okay, so this is where we use dy by dx to find the gradient. Okay, let's do a couple of examples. Well, we're one exam question with a couple of parts. So part A, it says find dy by dx in its simplest form. So again, hopefully you notice we've been given this function, but it's not an index form, is it? Do you remember what I was saying? So we need to change this. Okay, so we're gonna do some multiplying out of the brackets, and still this is still not an index form, is it? I need to I'm going to split the terms up and divide them all by x. So this gives me x minus 5 and minus 24 over x. And again, just one more step in this. We've got x minus 5, and remember it's got to be an index form. This last term, this is not an index form yet, so we need to put it in index form. 24 to x minus 1. Now you might think I'm flogging a dead horse here and going over the point too much, but honestly, you've got to get into this habit of changing these functions into index form before you differentiate. And now we are ready to differentiate, aren't we? So dy by dx equals, well, x, this is just 1x, remember? And so this just becomes, when we differentiate this, which becomes 1. Okay, any constant when we differentiate it just becomes 0. And minus 24, so we've got minus 24 to the power, times x to the power of minus 1. Well, remember this minus 1 comes out the front, so we times it by minus 1, and then x times, and we decrease the power by 1, so this becomes minus 2. And so I'm left with 1 plus 24x to the minus 2, and I can rewrite this one more time as 24 over x squared. Okay, and I'm done. That's my differential. That was 4 marks, that question. I think quite generous and hopefully easy to get. Now let's think about this part B. Find an equation of the tangent to C at the point where x equals 2. So we're thinking we've got a point of x equals 2. So remember, to find the equation of the tangent, it's going to be a straight line, y equals mx plus c. It's a straight line. We need two things, don't we? We need the point and we need the gradient. Okay, now let's just have a little look on our diagram again. Now I know that this isn't the exact curve that we're using, but it still works as an example. Okay, so here's our point, here's the tangent. So we're going to need to find this point first, okay? And we've been told that x equals 2 at this point, okay? So I'm actually going to fill that in. X equals 2, and we're going to use that to find the point. And then we're going to also use this point P to find dy by dx, okay? And then eventually that will give us this whole straight line, okay? So we know that x equals 2 and y equals, well, we don't know, do we? So we need to figure that out. I do know, however, that y equals, that's what we were given in the question. Okay, and I'm now going to sub in x equals 2 in order to find y. So y equals, well, so y equals, and I've replaced the x's with 2's. Okay, so this equals, y equals, well, this is just 5 times minus 6 over 2, which is minus 15. So therefore we've got our point, which is 2 comma minus 15. And the first part is done. Okay, now let's think about the second part. We just need to find the gradient of this tangent. To find the gradient of the tangent, we find the gradient at this point. So dy by dx, I already know, is, what did we find out in the first part, is 1 plus 24 over x squared. Great. I'm going to sub in x equals 2. Okay, so therefore I have dy by dx equals 1 plus 24 over 4, which is 1 plus 6, which equals 7. So I've now found my gradient. Okay, it's this thing here. So gradient, that's also done. And now finally, I need to just substitute this into my equation for a straight line. So we want to find this equation of a straight line. We know it's y equals mx plus c, and in fact, we know that it's y equals 7x plus c, don't we? Because the gradient, that m is 7. And now I'm going to sub in my point. Sub in my point 2 comma minus 15. Okay, so here we go. I get minus 15 equals 7 times 2 plus c. So minus 15 equals 14 plus c. So c equals minus 29. Okay, and just coming down here, my last piece of the jigsaw, rewrite the equation again with the stuff that I know. Y equals 7x minus 29. And I've finished. That's it. And if I'm feeling particularly happy, I can highlight it as well. That's the question done. I hope that makes sense. Thanks very much.